group is well known for its powder handling expertise, which is in use all over the world. What may be less well known is the diversity of challenging containment solutions which DEC are also creating.
I mean, the Isolator is a DEC integrated project, which makes us very unique in the fact that we can provide an isolator and also the powder charging technology to be able to charge products in sterile condition into a process reactor. Although it relates to animal health, we're working to exactly the same standards as humans. So whether this is going into the human body or whether going into animals, it's exactly the same.
Designing this particular isolator, which is for powder dispensing from multiple bags into process reactors, meant the DEC team had many constraints to consider, including room size, powder weighing, and the delivery of the powder.
This machine, although it's built really for a sterile application, there are certain products whereby we have to run this in toxic mode as well. So it's both protection of the operator but also protection of the product. Depending on which product we're using, we will run the system either in positive pressure for protection of the product or in negative pressure for the protection of the operator.
This process was designed for the containment of operator exposure band category 5 products and sterility.
The isolator is really used as a charging process in a sterility mode. The problem is that product is coming from an external supplier. This product is already sterile, but what means is it's in a sterile barrier. The problem is on the outside of the bag, it's not sterile. So we can't just introduce this product directly into the isolator, open the bag and charge it, because we would lose sterility. So therefore really, it's a charging isolator, but what we have to do first of all is we have to bring them into both sides of the chamber. Once we brought them into both sides of the chamber, we close the chamber down and we start the system. What we do then is we actually remove the outer bag and we dispose of the outer bag through the transfer chamber endless liner port. It doesn't need to be gamma irradiated or sterile. Once we've done this, we then hang the bags using our hanging system. We have a moving arm which in the lower position allows us to hang each individual bag in a validated position. The reason why this has to be in a validated position is once we've hung all of these bags, we will decontaminate the isolator using vaporized hydrogen peroxide. When we finish this first batch, we actually then transfer all the batches into what we call the charging isolator, and we physically close the door in between the two chambers. This means then that this main charging chamber remains sterile. There is an intermediate weighing process. We have a weigh scale mounted inside the isolator, and what this means is as the person is loading the product, they can pre-weigh this and we can send each target weight or each gross weight directly to the PLC, which in turn then goes directly to an MES system. The airlock chamber is then used as a fast gassing chamber. What that really means is it's like an airlock. It allows us to keep the main chamber sterile, the charging chamber sterile, but it allows us then to bring the next batch along and complete the same process as we did before.
This system uses DEC's own patented sterile powder transfer system. It's used in conjunction with the dispensing system for pre-weighed powder. This enables the safe, contained and sterile transfer of powder from the isolator to the process reactors.
With our system, we can charge very low minimum ignition or millijoule products. So from a safety point of view, it's good, but even better, we've now designed the system where we can transfer obviously liquid, so we can wash completely the line, but more beneficial than this, we can actually sterilize this line. So this physical line, both the hopper, the transfer line and the PTS, which is connected directly to the reactor, we can actually sterilize in place using steam.
The isolator's design was developed from the key requirements supplied in the client's user requirement specification, which is the first step in the validation process.
The big machine that we have in the present moment is just completed what we call our factory acceptance test. We actually have a physical area whereby we take the customer, and once we've finished the assembly and the initial commissioning, start up the equipment on what we call the pre-FAT. And the pre-FAT is actually going through the factory, each individual factory acceptance test before the customer comes. So the customer doesn't come, we turn the machine on and we think, oh, is it going to work? We've actually gone through this in detail and we've actually filled the protocol. Now, for me, this is absolutely essential, because if we don't do this, what the customer sees really is an untested machine, which can cause delays in the project, but also critical failures for ourselves as a company.
Whether it's a simple standalone contained system or a fully validated plant and control system to current GAMP standards, this Isolator demonstrates that the DEC Group are very much at home with this high level of technology.